Hi guys, let us look at this example number 5 here. In this case, we want to find the velocity given the position function and at a particular time. Guys, we know that the velocity is the rate of change of the position with respect to the time. And when we think in terms of the rate of change, we're basically talking about the derivative of a function. So all we have to do here is we have to find the derivative of the position function, and what we get is the velocity, and then we know at what time we have to calculate it. So let's go ahead and start writing or evaluating the derivative of this function, and then once we get it, we'll evaluate it at t equals to pi. Guys, look at this function. It is a quotient function and not too complicated function. So all we have to do is we have to start by using the quotient rule. The quotient rule is, guys, let me remind you the quotient rule here. Let us consider this as the numerator as my f and denominator as my g. So the quotient rule is f prime times g minus g prime times f divided by g square. And let us apply that here. So s prime of t, which is going to be my velocity. Guys, also keep in mind, sometimes the problem asks us to find the acceleration. So acceleration, we know from physics, is the rate of change of velocity with respect to time. So if I have to find the acceleration using the ideas of the derivative, first from position function, we calculate the derivative of position function, we get the velocity. Then we take the derivative of the velocity function, and what we get is the acceleration, okay? So, but in this case, we only have to find the velocity. So we just have to find the derivative once. So writing the derivative using the quotient rule, f prime. Derivative of cosine is negative sine t, right, times just the g function. What is the g function? Just times t minus derivative of t. Guys, keep in mind here, we don't have the function in terms of x, so we have to do the derivative with respect to t, okay? And then the derivative of t with respect to t is just 1. It's like derivative of x with respect to x is just 1. And then times the f function. What is the f function? Cosine of t. And this whole thing has to be divided by t squared. All we have to do is square the denominator. Let us simplify this further. What do I get? Velocity at time t is negative t sine t. I like to write the algebraic function in the front, and then the trig function, and then minus cosine of t. Whole thing has to be divided by t squared. Guys, this is a nice velocity function, but we need to find the value of this velocity, or we need to find the exact velocity when the time is pi seconds. Actually, this is supposed to be seconds, okay? And so we have to just substitute t equals to pi. So it is negative pi sine of pi minus cosine of pi divided by t squared, which is pi square. Guys, negative pi. Sine of pi, again, you may have to use a unit circle, or you can also use your calculator. But keep in mind that the mode should be radians, not degrees here. Sine of pi, guys, is just 0. And cosine of pi is negative 1. I kind of remember these because I have been like using it forever. Or you can use a calculator, a unit circle, or if you remember it, that is great too. And divided by pi square. Let us simplify this, guys. This is 0. Negative times negative is positive. It's 1 over pi square. That is the, and if I have to write the units, actually the units for the position were like feet. So this final answer is going to be 1 over pi square feet per second, because it's the rate of change of the position with respect to time. So feet over seconds is going to be the units for the velocity. Guys, that's how you would find the velocity given a position function. Of course, here we have to know what is the derivative of the cosine function. Like one has to know the derivative of the trig functions, and one also has to know the quotient rule. Guys, we use the combination of that and then some trig pieces as well. We have to know what is sine of pi or cosine of pi, and then finally we can find the velocity at given time. So guys, this ends the section on finding the derivative of trig functions. If you have any other questions in this section, feel free to reach out to me. I'll be more than happy to help you with any of those questions. Guys, after this section, I'm going to start with I think which is the last section of the text, like from the chapter that I'm trying to work on in my textbook. It is called the implicit differentiation. Guys, sometimes students find it a little tricky, but I want to make it a little easier, and I'm going to show you my ways and my techniques of actually dealing with it, which are really simple. And then we'll learn how to use these techniques and the new ways of actually finding derivative of functions using the implicit differentiation method. Till then, guys, take care. I will see you next time.